Welcome to another course of continuing education for professional engineers. Today we're going to talk about the integration of peak shaving facilities into a local distribution company gas system, and we will speak about gas outage avoidance. A little bit of information about myself. I'm a PhD in mechanical engineering. I have a master's degree in both mechanical engineering and civil engineering. I've taught undergraduate and graduate level engineering courses at a university level. I have 52 years of gas industry experience. I retired from Keyspan Energy in 2004 as Vice President and Chief Engineer. Today they're known as National Grid. I have 20 years of international and domestic experience in teaching and consulting on LNG projects across the country and around the world. I have a passion for LNG safety, for developing human resources, and for ensuring that our gas industry is reliable. Meet Margaret. She lives at 427 Cathy Street in Noborough Township. She is 67 years old, has 3 grandchildren. She is waiting for her tea water to boil, but it is taking so long. The flame is much lower than usual, so she will sit on the couch until the tea kettle whistle blows. Her area is about to experience a gas outage. That's why the flame is low. If not managed properly after she dozes off on the couch, her house may explode. Now meet the new Margaret. She awoke outside her house with her hair smoking. She never did get that cup of tea, and she gets real cranky when she misses her tea. But what really has her angry is that her house is no longer in its place, but scattered across the property. She does not know it yet, but her house blew up due to a mismanaged gas outage. What is the hazard associated with a gas outage? In a gas outage, low gas pressure may cause the flame on an appliance to extinguish. If the appliance is not equipped with a flame-sensing shutoff device, the valve that allows gas to flow will remain open. When the gas is restored, gas pressure is restored to the gas main, the gas will resume flowing into the appliance, which no longer has a flame to consume the gas. That gas accumulates in the house and reaches the explosive mixture range. The air-gas mixture finds the source of ignition and explodes because the house is an enclosed space. How low of a pressure would cause a flame out at an appliance? It's unknown because each appliance is different and each house piping setup is different. Some local distribution company operators use the following as guidelines for what they consider low pressure concerns. For a 60-pound system, they typically use 5 psi. That doesn't mean that you'll get a flame out if you get to 5 psi, but it's at the pressure that is of concern to the LDC operator. For low pressure systems that typically operate between 6 and 8 inches of water column, pressures below 4 inches of water column would be considered insufficient or of a pressure that would be a concern to a gas operator. Many gas appliances have gas regulators on them that are set to supply 3.5 inches of water column to the burner. Now, the numbers that I mentioned are not necessarily meaning that below those pressures you'll get an appliance flame out, but it's where LDCs typically get concerned about the potential for a flame out if the pressures get that low. The other thing to be concerned about is that where you're getting your pressure recording may not be the lowest point in your gas system. So a gas system analysis study would tell you where the lowest points are. And also the telemetry involved in getting feedback to the control center may not be accurate. We'll talk about that a little bit later on. But these are some of the concerns that we will address. So what are normal distribution operating pressures? They're dependent from company to company. But for the most part in the United States, it's very common to find 60 psi systems, and also in some of the older city, low pressure systems. 60 psi system has 60 psi gauge as its MAOP, maximum operating pressure, but it might typically operate between 20 and 50 psi-G. Inches of water column systems are typically found in the older cities, and these would be operated between 5 and 8 inches of water column. When you get down below 4 inches of water column, it starts getting to be a concern because of lower pressures being applied at the appliances. A gas outage can happen any time of the year, but LDCs are most vulnerable during the coldest weather conditions. I'll now talk about gauges and telemetry. They cannot be trusted for accurate readings. Here's why. You're operating a system for 10 years, you've never had a gas outage, and you're always looking at your gauges from the control center. And the question I have is, when was that gauge and telemetry last calibrated? You might have a zero offset, or you might have a span offset, or some false reading that you're getting and you're off by maybe 3 psi. Well, it's very much not a problem if you're operating between 20 psi and 50 psi and you have a 3 psi error. But what if you're operating and you're reading down to 5 psi and you have a 3 psi error? Well, that 5 psi may really be 2 psi, or it may be 8 psi. So depending upon telemetry information that has not been recently calibrated has a concern. The actual other concern that you deal with is, where is the low point in your gas system? You may have a feedback coming from your gas system that you think is near the low point, but is not the low point. So yes, you may be reading 5 psi, but maybe a 2 psi another half mile down the road, and that is not where you have a telemetry. So you need to identify where the low points are, and if you don't have feedbacks from those low points during a time of low pressure, you may want to send an operator out to the location to take a pressure at that low point. The pressure sensing location may not be where the gas system low point is, and that changes every year as load is added to your gas system and as the gas system itself changes its configuration. So it's important to review your gas system annually, do the analysis annually, keep your database of gas mains and services updated. The clear telltale outage indicator would be once customers start to call in complaints of low gas pressure or no gas complaints. The gas operator can be fairly sure the gas outage needs to be declared. Declaring gas outage is a serious matter. Once the gas outage is declared, the area affected needs to be isolated from the rest of the gas system. This can be easy or can be extremely difficult. It all depends on the type of system, the grid versus tree type of system, and the existing availability of valves to isolate the system. In low pressure systems, there are often no valves in the system or very few valves in the system, and isolation could be extremely difficult by having to isolate an even larger area than is necessary, but necessary because the valves that are available allow that larger area to be isolated, thereby not allowing gas to be flowing into the area that experienced an outage. Declaring a gas outage is a serious decision. Once a section of the distribution system has experienced low pressure, even if for a momentary period of time, the LDC operator needs to decide if the low pressure was sufficient to declare a gas outage. That decision is utility specific because every utility has its unique customer base and has its unique distribution system piping layout. If a low pressure is low enough to cause a flame outage and a outage is not declared, you run the risk of having gas accumulate in a building because an appliance was left on, an appliance that did not have a flame sensing valve. And that appliance, once gas comes back on, can bring gas into the house and have a gas accumulation. If the low pressure was not low enough and a gas outage is declared, it results in an extreme hardship to the customers, to the LDC, and to the PUC that regulates that utility. Once a gas outage is declared, the gas operator needs to ensure that gas is not restored to the affected area until gas service to every premise is either valve or shut off from the building so that no gas can enter the building. If it is suspected that a significant amount of air has entered the gas main during the outage, it will need to be purged out before gas is restored to the gas main. It is typical to do the above in subsections because a gas outage that is in any way a large gas outage cannot really be handled as one big chunk of the territory. Segregating significant areas and managing those areas separately allows the gas utility to bring the customers back online in stages. Field offices will need to be set up, and typically as many qualified persons as possible are put on 12-hour rotating shifts to restore the gas outage. Restoring gas service after an outage is complex. Once every premise is physically shut off from the gas supply, either by closing a service valve or by digging an opening and cutting that service to the house, and that may be necessary in the event no one is home, you can't gain access to the house, and there's no external shut-off valve for that building, then you may have to dig a hole and literally do a cut and cap on that service in order to continue the restoration and come back to that house after the gas is restored. Every gas appliance in each premise must be shut off physically at the appliance. If for some reason the apartment cannot be entered or access cannot be gained, that premise cannot be gassed in. Once every appliance in a building is physically shut down, gas can then be restored to that house piping. Once the gas is restored to the house piping, then every appliance must be relit by a qualified person. Record keeping can be a nightmare during a gas outage. You have to keep records of every single premise and whether they were able to gain access, whether they're able to shut them off, and whether they're able to do the relights. And you may be dealing with personnel from outside of your immediate area if you have mutual aid helping you out. So it's typically a nightmare to keep the records of every building, every premise, every apartment it may be where you're dealing with apartment buildings. Checking and double checking is critical, as one mistake can result in an explosion. Making sure each operator's qualifications are up to date for the work and for accounting for their hours worked is also critical. It's a large clerical task, as many personnel will be needed from many parts of the operating company. What will be the impact on customers? Well, that depends heavily on how big the outage is. If it is in winter, the impact on customers can be quite severe. Many customers without heat will relocate to relatives or to shelters, and persons in critical care facilities such as nursing homes and hospitals may need to be relocated. This type of stress in extreme cases for the very fragile can result in worsening of health or death. House water piping may freeze up, resulting in severe water damage to those buildings. Even nearby shelters, or what would be considered shelters, may be without gas, so the actual shelters used may be inconveniently far away from the affected area. Local restaurants, businesses will likely be closed down, causing an economic loss and unemployment for workers. The local economy will certainly take a hit. Perishable foods may also be destroyed if that gas supply also supplies regional power generation. And what is the impact on the local distribution company? Responding to an outage is an all-hands-on-board event. Racing against the clock is critical, as the longer the premise is without gas, the more hardship the customer experiences. The more risk there is to the piping freezing up and air may enter the gas main or the house piping. Restoring a gas outage may take one or many weeks until every appliance is relit. The cost of an effort is staggering. Monitoring of personnel, fatigue, and mistakes is a critical task that must be taken care of to make sure that no errors are made during this very unusual occurrence. More on the impact on the local distribution company. Regardless of the cause of the outage, the reputation of the gas distribution company will be damaged. If it is found that the outage could have been avoided by prudent preparations by the gas operator can be liable by fines or lawsuits. The local distribution company will need to literally settle with each customer that was inconvenienced. The cost of the entire outage restoration will be significant and may be deemed as not recoverable through rate increases. The gas not sold during that outage will result in a loss of gas revenues. Events that have or nearly have caused gas outages include an electric outage across several states resulted in multiple gas compressor stations shutting down. Gas pressures at the receiving LDCs became alarmingly low. Extreme cold weather on a gas system that has not been adequately reinforced. Extreme cold weather on a gas system not designed for such weather, such as when the wells froze up in Texas and they had a very cold couple of days in Texas, and this happened several times over the past 2 decades. And then there's always equipment malfunctions that could cause a gas outage. Other events that have or nearly have caused gas outages include operator error, operating the wrong valve, shutting a wrong valve during maintenance, pipeline rupture or physical damage to the pipeline, incorrect data input into the flow prediction software. Typically Synergy is used, but I'm not endorsing any particular software, but that's one that I know a lot of companies are using. Physical sabotage, cyber tampering with the telemetry, interruptible customers consuming when they're not allowed to burn. You get a point in time when it gets real cold and you tell your interruptible customers to come offline and they stay online, well, they're going to be reducing the amount of gas that's available for your firm customers. Rolling blackouts during extremely cold weather. I'm going to give that special attention. We'll talk about that on a separate slide because that is a unique type of gas outage that can be extremely difficult to manage. What is the role of LNG in preventing outages? LNG assets are within the gas operator's territory and is fully under the gas operator's control. That is a big plus because it isolates the LDC from events that take place outside of this territory, maybe upstream on the interstate pipeline or across several states where I mentioned earlier, like an electrical outage across several states causes a shortfall. So having those assets right within your territory allows you, the LDC, the ability to bring that gas online very quickly if it is so configured. The system is not affected by events outside of its territory, so it has control of this LNG asset, but it's not as easy as it sounds. LNG assets must be ready to come online when an outage is imminent. So during the winter, it's typical to keep those assets online, ready to go. When that equipment is in standby, pumps can take anywhere from 12 hours to cool down in some configurations. Other configurations can come online within a minute. If the piping is already cooled down up to the vaporizer header, then vaporization can start within minutes. So it really depends on your equipment readiness for service as to whether your LNG assets can be used to prevent outages. Also realize that your LNG outages, your LNG portfolio, your LNG assets are part of your peak day portfolio for gas supply. So you have that equipment ready for peak day as well as ready for outage prevention. It is critically important for a utility to run reliability analyses, and it's typical to run them at least once a year. It is critically important to do a diligent reliability study of your entire gas system. In doing that, you need to make sure that all your data sets are updated, meaning that if there's a cut and cap in the territory, that it is reflected in your Synergy or your whatever software you're using for your analysis. Each critical main and facility in the distribution system needs to be ranked with a well thought out probability of failure, and that value needs to be a key parameter in the analysis of where to place an LNG facility. This value needs to also be used in creating the design basis for your LNG plant. Also, the potential for interstate force majeure needs to be considered when creating and designing your design basis for an LNG plant and for where you're going to locate that LNG asset. The question is why LNG, not CNG or some other means of avoiding an outage by having storage within the territory. LNG can be located within the distribution company's territory, and that's one of its biggest advantages. LNG is the most compact form of natural gas storage. LNG can also be trucked to portable pipelines to support hospitals in an outage-affected area, thereby avoiding the need to relocate hospital and nursing home patients. And when should LNG be considered for reinforcing or preventing outages within an LDC? All too often, the latch is put on the barn door after the horse gets out. Our job as prudent gas operators is to be proactive in protecting our customers. It is prudent to prepare for an outage before an outage, not after an outage. Think long term. It will take at least 5 years from the time of conception to the time of commissioning for putting an LNG plant into service. Build larger rather than smaller because 5 years is a long time, and during that 5 years, load may grow and your vulnerabilities may increase. Your needs will be an additional 5 years out. So plan the tank size and the projected needs of vaporization 10 years out instead of 5 years out. And also plan for future expansion. If you're purchasing land, perhaps you want to purchase enough land for additional tank in the future or for additional vaporizers. Also, make sure you consider interchangeability of LNG wherever you're placing that LNG facility. Boil-off gas may have a higher heating value of 1,000 BTUs per standard cubic foot. Vaporized LNG may have a higher heating value of 1,100 BTU per standard cubic foot. Wabi number of bog and vaporized LNG will always be different, and the pipeline gas will be different as well. The higher heating value and Wabi number of the bog mixed with rejected gas from the liquefaction system will also be different than both bog and vaporized gas, and also different from pipeline gas. For areas where therm billing is a consideration, all of these factors have to be taken into account so that you don't end up having customers that are in a fixed zone, therm billing zone, receiving gas at 1,000 BTUs at one point, 1,050 BTUs at another point, and 1,100 BTU gas at another point in time. There are limitations to using LNG. LNG can help, but there's a limited quantity available. If you have a 1 BCF tank, at best you'd be able to get 0.9 BCF, and that's because you're never really at the high point or the maximum fill of your tank, and you never really can draw the tank all the way down. You need to have a heel in the tank. Vaporization capacity is limited to the vaporization that's at the plant. You cannot exceed what your vaporization capability is, so meeting challenges of very high curtailments of natural gas can be difficult, and you could end up with an outage even if you have LNG available. An LNG plant is a complex conglomeration of components that must all work in symphony in order to do send-out, and it's not as reliable as a pipeline supply. So reliability of the LNG facility is certainly an issue. Perhaps the LNG facility is experiencing maintenance at the time when a shortage occurs, when a pipeline shortage occurs. Also, you need to have other systems all in place, such as odorant systems and all the support systems for the LNG plant. An LNG plant is not always full and ready to come online. An LNG plant has limited capacity, but it is usually enough to handle a short-term emergency, and of course it depends on the magnitude of the emergency. When we talk about reliability of an LNG facility, we're talking about when you need it, is it there? And if your pumps are warm, it is not there in a short time frame. Warm pumps typically require about 12 hours to cool down. And cooling down the line from the pumps to the vaporizers typically takes another hour. It can be sped up in an emergency situation, but that pump cool down cannot be sped up. If you have in-tank pumps, well, then they're always in the cool down state, and those will always be ready to operate. However, you still have to cool down the line from the pumps to the vaporizers. Odorant systems must be functional. So even if you have the LNG and everything's ready to go, but your odorant system is out of service, you're not allowed to put send-out into the gas pipeline system because it would not have odorant, which is required by code. ESDs must all be cleared. LNG pumps must be cooled down. Piping must be cooled down. Vaporizers must be ready to operate. Let's say you have water submerged combustion vaporizers. Well, they need to be filled with water and ready to operate. Any kind of vaporizer maintenance that's taking place would certainly make those vaporizers not operable if they're in the middle of such maintenance. Personnel must be trained and on site. LNG must be in the correct location to alleviate an outage. If you have an outage on the west side of your territory and your LNG is on the east side, it doesn't do you too much good. However, the LNG facility has a capability of coming online if you have advance notice of a force majeure situation. One of the concerns is the capacity of your LNG tank. If you're running partially into the winter, you may have already used up 40% of your LNG tank. So to say that you have 90% of your tank available is really only under ideal conditions. Fact is, 80% would be fortunate if you had that much available. You also have capacity of your vaporization. Vaporizers might be good for, let's say, 100 million a day. And let's say you use them for that 100 million for one day. It's going to take you how much liquefaction time to make up 100 million? Typically, your liquefier is about 5% of your vaporization capacity. So if you have a 100 million a day vaporization capacity, you might have only a 5 million a day liquefaction capacity. That means that it'll take you 20 days to refill one use of vaporization at max vaporization. But in reality, you also have boil-offs to take care of. So it's going to take you more than 20 days to refill one full day of vaporization capacity. So let's take a look at the amount of time it may take you to refill. Let's say you've already used 300 million standard cubic foot from your LNG tank. Assume you have a 1 BCF tank. Well, at 5 million a day refill time, it'll take you 60 days to make up 300 million. But you also have to take care of boil off. So there's another 6 days. That's 66 days. Let's say once during that time you have a shutdown that requires you to derime. That means warm up the plant. Well, there's another 6 days lost. So already you're up to 72 days of time that's needed to make up that 300 million standard cubic foot. Well, you could look at trucking in LNG, but even if trucking in were to be used to refill, an LNG tanker only holds 0.8 million standard cubic foot of LNG equivalent. So you're talking about, to fill up 300 million standard cubic foot, you're talking about 375 tanker truckloads. And that's not including the flash gas and the bog or any other shortages that may occur during your unloading. Like you may not get a full 0.8 million standard cubic foot in a tanker truck. A derime and a restart may interrupt filling up the LNG tank, and that's a derime is when you warm up the liquefier because it had frozen up or for some other reason you had to warm up the liquefier. And deriming means to send warm gas through the liquefaction plant and dry out any moisture or any solids that may have occurred due to heavy hydrocarbons or carbon dioxide or water contaminating your feed gas. The above assumes that liquefaction or truck loading component is 100% functional, and that's another issue. If you're caught at a time when your liquefier is down, or if you're caught at a time when trucking is in high demand, you may not be able to get the truckloads to do a refill. When you're looking at where to install an LNG facility, there are many factors to be concerned about. One of them is therm billing concerns. The higher heating value of bog, that's boil-off gas, may be 1,000 BTU per standard cubic foot. The higher heating value of vaporized LNG may be 1,100 BTU per standard cubic foot. The higher heating value of regen gas plus boil-off may average between 950 and 1050 BTU per standard cubic foot, and will have peaks and valleys of CO2, nitrogen, and heavy hydrocarbons in that concentration. A feed gas of 1% nitrogen could end up with a tail gas of 20% nitrogen going out to your customers as flash gas mixed with boil-off gas. That's an extreme. I've seen 12%, but it could go as high as 20%. So you have to be concerned about what's going out your tail gas. Can you dilute it enough so that it's not going to see these extremes? CO2 releases during regeneration will also spike. Initially, when you start to regenerate a mold sieve, you get high levels of CO2 coming out and high levels of water vapor. The water vapor won't harm your customers too much, but certainly the CO2 could change the burning characteristics and the interchangeability of that gas. If heavy hydrocarbons are added to the bog that is rejected, that will raise the higher heating value. So dilution gas may be needed to maintain interchangeability of your tail gas in your liquefaction during liquefaction. Do realize that the LNG asset is quite often part of your supply portfolio for peak hour load requirement. For this particular LDC, you can see there are 3 suppliers plus the LDC facility that are required to provide natural gas to the pipeline during a peak hour. In this case, it's showing 10 million standard cubic foot per hour coming from the LNG facility. Now, if that 10 million was not available, you'd have to get it on the spot market if it can be delivered, or from some other supplier if it could be delivered. I say if it could be delivered because on peak day, typically your pipelines are flat out and delivering all of their capacity that's possible. LNG plants rated maximum send out is 20 million standard cubic foot, and the storage is a 1 BCF tank for this particular facility. And the reason why I show this is that you notice the 20 is greater than the required 10, and that's because of prudent thinking in the event you ever need to have that extra capacity. For instance, if supplier 3 for some reason does not come in with their supply requirement, then you'd have to supplement with more LNG. You've heard the expression size matters, and for an LNG facility it certainly does. Plan for the future. When planning an LNG asset, plan well into the future. Think about storage size, vaporization capacity, takeaway capacity of your pipeline, and at what pressure. Additional land for future expansion. Perhaps you want to put an additional tank in or additional vaporizers. High pressure LNG send out has some preference because that can go directly into the transmission system and reach a large part of your territory. I drew here a hypothetical gas territory, and as you can see, the gas territory is bounded by this irregular shape. It's got the ocean beneath it, the ocean to the right of it, and land above it and to the west of it. Now, it's supplied by 3 interstate pipelines, as shown here. This one happens to be fed off of a import terminal, and I've just hypothetically put in some transmission lines within the territory, and they all have spurs on them, and there are drop-down regulators that go to various pressures. 60 pounds per square inch is typical, and this whole area that's in the territory is supplied by these 3 pipelines. And I'm thinking about putting a LNG facility in here. If I knew nothing else, I'd say here's a nice place to have an LNG facility, and the reason is because I can supply all of this all the way up to here, and I can supply all of this all the way out to here, and all of this as well, cross over here as well, all the way up to here I could supply. Now I may even be able to supply some of the 700-pound system if the piping was so arranged so that this could pass 500 psi across to here. Now, when would I have to do that? Only if it's a summer month and there's some kind of a force majeure on the pipelines, and I have a very low load, because I can't expect this LNG plant to capture or be able to supply the entire territory unless it happens to be perhaps July 4th when the load is exceedingly low. Slide, I looked at where I'd put an LNG facility, but I did not base it on an analysis. What you really need to do is do a rigorous analysis of, okay, what would cause a gas shortage in my territory, and where would be the best place to put an LNG facility? What is the reliability of this pipeline supplier, and this pipeline supplier, and this pipeline supplier? Historically, how reliable have they been? And also, what is their exposure? Are you at the very end of the pipeline from Texas and Louisiana? And this is just, you're up north, let's say in the Northeast, so you're at the very end of this pipeline. That leaves you very vulnerable. So you attach rankings to each of your supplies as to what their vulnerability is. And then you look at potential line breaks, a break here, or a break here, or a break here, or a break here, etc., or somewhere here, or here. And then you apply to that ranking, okay, if you had a break here, how many customers would you lose if you ended up not having the an LNG facility? And then if you had a break here, how many customers would you lose if you did not have an LNG facility? And then you do that matrix and then look at what location would give you the best coverage for reliability for your territory. Now you may end up finding, oh yeah, here's the perfect spot, but it may not be able to put an LNG facility there because it's a politically sensitive area. Perhaps it's a very high income area and there's a lot of political, or I should say public, which results in political pressure not to put an LNG facility there. You may end up having to put it somewhere else in your territory. Looking at this picture, I'd say it would be nice to have an LNG facility here and a satellite facility out here. And this would cover me pretty well for a lot of different scenarios. But that's done without having the analytical data to look at the reliability analysis. When performing a gas system reliability analysis, you look at single point failures. You quantify the single point failures. What's the probability of that line having that single point failure? And then what would be the consequence of that single point failure? And in doing that, you now have an understanding of, okay, the probability and the consequence can be merged together to give you the risk associated with that particular form of an outage. It could be a line break. It could be a interstate supply that cannot supply the gas needed. You look at things like historic reliability of each of the interstate suppliers, the SMIs of each in-territory pipe. That's the specified minimum yield stress. The higher the SMIs, the more potential there is for a rupture to occur. Now that doesn't mean that running high SMIs pipe is not allowable, but if you have some pipe that's a class 1 pipe, it's going to be operating at a higher stress level. You do a synergy analysis to look at the number of customers that would be lost for a break on any pipeline in the territory at various temperatures. Then you do a risk matrix for the various line breaks and locations of an LNG facility and see how that location for that facility would impact that risk matrix. You put it in a ranking order of the best placement options to the least best placement options. You overlay that onto the opposition to the LNG facility that we spoke of earlier. That's political and public protest, and you determine the best technical location. If the worst happens and you do have a gas outage, realize that it's quite difficult to isolate the area that had the gas outage without taking a larger swath of the territory. For instance, let's say there was a gas outage that occurred in a territory that's fed by a grid system. Here's a grid, and consider these to be, let's say, each of these is a city block. And if this is the area that experienced the pressures that were not acceptable, you'd have to shut off each of these lines with, hopefully there'd be a valve associated with it. But if there's no valve, you have to actually dig up and cut and cap these lines to isolate this area. If it's a branch system, you're in a much easier situation. You can shut, in this case I made it a single valve to take this entire part of the territory off the grid, so to speak, and now you can do your isolation of the buildings and your part by part relight. In this case, you'd probably bring gas, you'd isolate all the building services from here to here, and then you would do a relight on all those appliances. Then you'd open this valve, do the same here, open this valve, do the same here, open this valve, do the same here, making sure that you've secured each building as being shut off from the supply of gas before you bring gas back onto the gas main. Gas outage prevention and mitigation measures. Having a load shedding plan is important. A load shedding plan has areas of the territory that can intentionally be cut off, which would prevent a large-scale outage by literally removing small sections of your territory from the gas grid. An analogy would be removing an arm so that the whole body lives. It's not an ideal situation, and the customers that would be involved in the load shedding area would probably complain loudly if they know that they are pre-targeted as customers to be load shed in the event of a supply disruption. It also requires all interruptible customers to actually come offline when they are required to. And I say actually come offline because quite often when you have to call an emergency and tell your interruptible customers to come offline, many of them continue to burn. And that can cause a large-scale outage if they don't actually come offline. Your predetermined areas of value have to be valued by load that they consume, by the demographics, the fairness, the consequence of shedding that area, and your ability to cut off that area and to restore that area after gas supply comes back. You should also have a crisis management plan, and it's a plan that's different than a load shedding plan, but it may be used during a load shedding plan. A crisis management plan tells all departments within the company what they need to be prepared for. Perhaps there's a shooting at one of your facilities, or an explosion at a facility, or even some civil unrest outside the facility. Well, your security department would know what they need to do. Your public relations group would have pre-canned messages that could go out. Your human resources group may need to bring in grief counselors. Procurement may need to bring in cots and bedding so that crews can stay overnight and continuously man that facility until the emergency is over. LNG plant readiness, we spoke about that several times. You may want to consider that during the winter, keeping your facility in a cold state continuously during the winter. There's a cost associated with it, but that cost is part of what has to be weighed when you're looking at prevention and mitigation methods. Annual reinforcement analysis, where you look at your system. The gas system changes during the year. So every year you need to look at it from where reinforcements are required in order to maintain your system even under non-force majeure conditions. But if you have a design day, you want to make sure that all areas of your territory are adequately reinforced. And then doing also an annual reliability analysis. We spoke about how to do that. We prepare a matrix and you look at the consequence of how many customers could be lost if you had a line break or some other load interruption occurrence. This is a hypothetical load shed plan. Here's two areas of the territory that would be very convenient to just isolate if valves are in place to do that isolation. In this particular case, it looks like only two valves would be involved. Now, there may be more because you might have 60-pound systems that go beyond this area and crisscross this area, reconnect from here to here, etc. So it has to be looked at and analyzed by engineering. Here's another area that looks like it's a peninsula that could easily be load shed. Now, one of the concerns in this area, because there's ocean on both sides of it, and the same with this area, I'd be concerned about wind chill that could occur in this area. So the customers in this area may be more highly impacted than other customers. But again, we're removing the arm to save the entire body. Now, will these be the right areas to load shed? That depends on the analysis that needs to be done and the number of customers and the amount of load that's associated with it. But having a load shed plan is an important preventative measure that would mitigate the consequence of an outage. This might be 10,000 customers that have to be restored versus 100,000 customers that have to be restored. And the larger the restoration area, the more complex it gets. It's not a linear relationship. As you go from 10,000 to 100,000 customer outage, the complexity grows exponentially. Having recovery equipment and procedures in place in advance of a gas outage is a good practice. Load shed plans written and procedures and drills performed will help your staff be ready to manage a load shed event. All administrative forms for addresses, contact information, gas service information, and load information for the designated load shed areas would be pre-printed and ready to go. Mobile command centers would be available. Perhaps they're in the equipment yard now and ready to roll with all the necessary equipment. You don't want to come and find that when it's time to roll out your mobile command center that the battery is dead or that the radios don't work or some other consequence like that. Up-to-date organizational structure is important. An updated list of qualified isolation personnel. These are people that are qualified to operate valves and relight. Updated list of qualified supervisory personnel. An updated list of qualified relight personnel. All of these things are important so that if an outage has to occur, you can do your load shedding in a very effective way and a very organized way. You can also make strategic use of LNG assets. Advanced plans to maintain hospitals and shelters heated and supplied by LNG portable pipelines is one method. Analyze in advance what pipelines need to be connected to your LNG facility to make it most effective during an event that might result in an outage. We looked at the territory earlier and I said here might be a good place for an LNG facility. Maybe along with that LNG facility might be a run of 2 miles of piping to interconnect it to another large section of your territory. This is the type of analysis that needs to be done in advance. Understand in advance the availability of trucked-in LNG assets, such as portable pipelines. Plan on these events occurring and drill on them, and have mutual aid programs in place. Mutual aid brings in assets from other companies to help you in the event you have a gas outage, and it also provides your personnel to the other companies in the event they have a gas outage occur. This picture is the back of an LNG truck that is hooked up with the hoses to provide LNG to a portable vaporizer. The portable vaporizer will vaporize that LNG, odorize it, and then send it into the distribution system. These are good applications for maintaining facilities as well, such as a hospital. That's a hospital that may be in an outage area, and you need to keep that hospital online. This would be one method of doing that. Portable pipelines use LNG tanker trucks, and each LNG tanker truck can carry an equivalent in standard cubic foot of 0.8 million standard cubic foot. This is a portable heating system that's providing hot water ethylene glycol through these pipes to a vaporizer. Now the reason why this looks like this is because the vaporizer is transported, usually sitting right here, but you want to have the vaporizer ideally a distance away from the sources of ignition. In this case, source of ignition would be the boilers and the electrical equipment that's here. So in this particular case, the skid comes on site, the vaporizer is put at least 50 feet away, and heating lines are connected. This vaporizer is good for 250,000 standard cubic foot per hour. And that's provided that you have an LNG truck that's providing the LNG to the vaporizer itself. And this is the LNG vaporizer itself for that particular unit. You see the lines with the hot water ethylene glycol shown here. One's a supply line, one's a return line, and you see on this end is where your LNG hookup would connect, and you also would have the outlet of the gas supply that would be feeding into the distribution territory. One of the things that's critical is you can't stop the flow of LNG, so you need to have trucks that can be available. One is feeding, the next one is connected onto the same manifold and ready to feed, so that you get an uninterruptible supply of LNG to these vaporizers. This was a location that was set up to maintain an entire town on natural gas supplied by portable pipelines, and that was for a 6-week period of time. And you can see there are 3 large vaporizers here. Now these are different than the one I showed you. They're not modular and separated. 3 large vaporizers. In here is a water bath, and in that water bath you have, I say water bath, it's typically water ethylene glycol mixture or propylene glycol mixture. But you have these water baths, and you have a furnace that's blowing hot combustion gases through tubes in this water bath and exhausting the exhaust products. Same as showing here. In this case, you have the heater and the exhaust stacks showing here. You have the LNG hookups as well going to the vaporizer. Here you show the LNG truck itself. There's actually 3 trucks on this site, but the other 2 are not showing. Here are the 3 trucks that are on site. Typically, when one empties, it will go back and fill up, and the other 2 will stay on site to provide a continuous flow of LNG to the vaporizers. In this case, when that other truck, the full truck comes in, then the next nearly empty truck would head out to be refilled, and this would continue 24 hours a day until the outage is over. In this particular case, this was a town that was intentionally isolated from its interstate transmission system because the interstate transmission system had to be upgraded. When using portable pipelines, it's typical to pressurize the truck itself by using these coils that are underneath the truck. Some LNG is put through these ambient coils, ambient heat exchanger coils, and that causes vaporization, which pressurizes the truck and allows the gas to be pushed through the vaporizer. Now that'll only work if you're dealing with systems that are typically 60 psi or lower. If you want to go into a high pressure system, let's say a 250 pound psi MAOP line, you would then have to have LNG pumps associated with the portable pipeline. But if it's a lower pressure system, you can just pressurize the tanker truck, and that will push the LNG through the vaporizer. This is a 200,000 standard cubic foot per hour vaporizer, and as you can see, there's a stacks over here, and knowing this vaporizer how it's constructed, there's a burner is on this end. It blows the combustion gases through tubes that go back through this water ethylene glycol mixture, and then the exhaust goes up the stacks. It also has a pump that continuously mixes that glycol water and continuously creates flow across those tubes. And here is where the manifold, where your LNG would be hooked up and your natural gas would be coming out of the manifold. It's a split manifold, so that it has in here a separation. On one side would be LNG going down tubes, coming back as vapor, and on the other side you'd have the outlet vapor go out and go to the pipeline. This is a view of the same vaporizer. As you can see, an attempt was made to build a dike around it using sandbags. In hindsight, it probably would have been better off using some other means of providing a dike, because just thinking about it after the fact, I don't know how well the bags themselves would hold up on the cryogenic temperature. The sand will hold up, but what about the bags themselves? That's only a thought that came to mind just yesterday, actually, re-looking at these slides prior to making this recording. I hope that didn't work. In this slide, we see two ambient vaporizers rated at 60,000 standard cubic feet each, and they are nothing more than finned tubes that take ambient air to heat up the LNG. And one problem with these is that they do ice up, and they also cause a large vapor cloud of just moisture, not a vapor cloud of LNG vapor, but moisture, and that can be alarming to the public that comes by and see vapors coming off your work area. Another downside of using ambient vaporizers is if it's cold outside, you're going to need a trim heater. Let's say it's 30 degrees outside. Well, the best you're going to do is to get your LNG vaporized to 25 degrees. And then you need a trim heater to bring it from 25 degrees up to 40 degrees before putting it in your pipeline. You'll also note that some temporary piping was put in place here. Rigid temporary piping was put in place to get you to the vaporizer, and then the flexible connection was put from that piping to the vaporizer. And this is nothing more than the connection from the outlet of the vaporizer to the pipeline that's going to be supplying that town. This happened to be a 4-bar system, which is 60 psi. This slide shows the ambient vaporizers in the background, and you can see the vapor cloud that I mentioned earlier. This is just another view of the ambient vaporizers, the attempt to make a dike area around the vaporizers, and the vapor cloud. On this site, we made sure that we had not only a good electrical connection supply for the vaporizers and heaters, but also brought in an emergency generator just in case we had a power interruption. Last thing you want to do is have an outage in a town when you're supplying it by way of portable pipelines, and you have the outage anyway. If you want to consider really how bad can it get, think about what would happen if an electric rolling blackout were to occur at the same time as having a peak gas demand day. Most of the year, a rolling blackout of electricity would not impact the gas system significantly. However, on a peak day, it would. And here's why. The supply of gas that comes into an area is supplying many boilers or heaters that are online. Some of those boilers have just satisfied their thermostat requirement and are offline. So if an electric blackout occurs, every heater in that area would be shut down for that period of time of the electric blackout. And then when the electricity is restored, every heater would be calling for gas in order to fire. And due to that, you lose what's called the diversity of your gas load. The diversity of the gas load means that even during the coldest weather, there are times when some of the boilers will be off. At any given time, a certain percentage would be off and a certain percentage would be on. After an electric blackout is finished and they restore electric power, every thermostat would be calling for gas, and the system is not designed to provide that level of gas supply. For whatever reason, if there is a shortage of supply on the interstate pipelines in an area, both the gas supply and the electric supply to an area will be affected. And this is due to the fact that many electric generators are all using natural gas for their electric generation. To avoid a large regional blackout, electric distribution companies may resort to rolling blackouts. Rolling blackouts shut the electric service to a localized area for a period of time. As I said earlier, most times of the year, they would not impact significantly the gas system. However, if a rolling blackout occurs during periods of high gas demand, such as on a peak day or peak load day, peak gas day, peak load day, such rolling blackouts can result in natural gas outages. The gas distribution system piping is designed to account for the gas loads that have a certain degree of what's called gas load diversity. The gas load diversity means that even on the coldest day, highest load hour of the year, a number of thermostats will not be calling for heat because they've just reached their thermostat set point. However, during an electric blackout, as in a rolling blackout, the majority of gas heating systems shut down and the building would cool down to the point where nearly all load diversity will be lost. Also, during a rolling blackout, most of the LNG facilities will be knocked offline due to a lack of electricity. So it's a double concern during a peak day if an electric blackout occurs. One, the loss of diversity of your load, and two, the loss of LNG facilities that have supplied electricity by that grid. More about electric rolling blackouts. When the electricity comes back online, every thermostat in the affected area will call for heat. This will overwhelm the LDC's piping deliverability because all load diversity will have been lost. Even if every supply point was delivering at its design capacity, the gas load would be well above the piping pressure drop design. Every LNG facility that had been knocked offline due to the blackout would not be readily available to come back online. An LNG plant restart may take up to 10 minutes or even more than 10 minutes. After the LNG plant restart occurs, ramping up to full send-out may take another 5 minutes. During this startup and ramp-up, excessively low pressures would be likely to occur in the distribution system. What do historic gas outages tell us? Gas outages result in severe customer welfare risks. They may even result in the loss of life. Potential need to relocate customers to places of temporary shelter would be required. A loss of customers' trust in the LDC would occur. Damage would occur to the economy of the affected area. Potential lawsuits against the LDC may occur. A restoration that may take a week to achieve 90% recovery, even with mutual aid, may take many weeks to get to complete restoration. The potential for significant property damage would exist: frozen pipes, perishable goods, etc. So what is the industry's best practice? It's to do everything possible to avoid a gas outage. As it said, if Margaret ain't happy, ain't nobody gonna be happy. Margaret's our customer, and our obligation is to keep gas flowing 24/7, 365 days a year.